Could you please hand me the ducky? Oh.
That's on this robot. As you can see, it's looking at me. Hey.
Hey.
Welcome back, everyone. Did you ever encounter this, where you are stuck programming a robot or software, and you just couldn't figure out how to solve this problem? And after hours of frustration, you go to your coworker or your friends, and you started talking about your problem. Then all of a sudden, without them saying anything back, you realize, oh wait, I think I have a solution, and I know what the problem is. Well, this is a pretty common problem that people have. And in fact, it's so common that someone came up with a rubber ducky debugging method. The point is, you have a rubber ducky and you just talk about your problems. But there's a problem here. While I'm filmmaking or programming, my hands are always tight. So I don't have hands to pick up rubber ducky when I needed it. Wouldn't it be a better way if there's a robotics arm that could pick up the duck when I needed it and just start talking at it? Or even better, just find where I am and give the rubber ducky to me. I think I have a solution for this. So last year, I won a robotics arm from a competition, and ever since, I've been looking for things to do with this arm. I also reached out to the Elephant Robotics, who's the sponsor of this project, and they were kind enough to send me some extra components. Here we have a myCobot 280 Raspberry Pi version. I have a flexible gripper and a USB camera that goes with it. The installation was fairly easy. They have this kind of Lego-like pins and holes for you to install. So it's pretty modular to adapt to any other accessories. And who needs the hammer when you can use your hand? Okay, got my robot arm set up. It's connected to the table so it doesn't move around. And then I'll try to connect with my laptop so I can remote access, and it will do some programming over there. After that, I quickly read through the documentation to use Python and their library to control the gripper and bring up the camera feedback. And here's a quick test to move the arm in different ways. Doesn't this look like the lamp from the Pixar movies? By then, I have a pretty good understanding on how to control the robot, so I was testing it out to see if I can pick up a rubber ducky. Now that we got all the basic programming down, the next step was to utilize the camera and to detect my face. Thankfully, this is something I've done before. If you remember my T-Bot project, that's the same library I was using to detect my face. So we're going to quickly deploy this library and see if we can run it on the Raspberry Pi alone. Turns out the camera processing takes a while when you're accessing remotely. But anyway, I got it to work. The logic for a robot to follow my face is very simple. All I have to do is when I detect a face and it crosses the center of the camera, then I follow the direction of where it's going. For example, if my face is heading to the left side of the camera, then I have the arm to move to the left side to compensate, and vice versa. To make it even more robust, I calculate the distance between the center to my face and use that as a multiplier for how fast my robot should be moving.
Yeah, so I finally got the face tracking to work on the Raspberry Pi that's on this robot. As you can see, it's looking at me. Not the fastest, but I'll look up, and I'll look down. It's the height a little bit, just to look at me. It reminds me a lot of the dummy E from Iron Man.
For lack of a better option, dummy is still on fire safety. If you douse me again and I'm not on fire, I'm donating you to City College.
Where that robot would just look at him and do some silly stuff that it's not really even helping him as he builds his robot suit. Okay. Something I like to do is like, hey, look at this cup and then record this or something like that instead of tracking my face, because it's actually kind of weird to have a robot that's just like following you and looking at you the whole time.
And that's where we're gonna have it detect rubber ducky, so it wouldn't be as dummy. In the computer vision world, we have this thing called the HSV tuning. In a simpler term, we have color detection that is in the HSV domain. To do this, we're going to tune a upper bound and a lower bound to specify the color of the yellow rubber ducky. So when the camera sees it, it will detect this yellow color and we will determine that it is in fact a rubber ducky. From there, we can then say, okay, this is the size of the rubber ducky and this is roughly the estimate of where the rubber ducky is. And here's the final result of a well-tuned HSV. You can see it also tracks pretty well on my hand. In addition, it is reporting the position based on the camera in pixels. Finally, we need to tell whether camera sees is relative to the robot. Usually, there's a calibration process needed to be done for the camera and the robot arm. However, there's a simpler way to do this. The way I do it is you measure the distance between rubber ducky and the robot arm in pixels. And then you measure that with millimeter distance, and that gives you the ratio.
Okay guys, we have a major problem. I got it to work, but here, take a look. It does grab it, and it's barely hanging in there. Oh. Okay, let's try it again. Comes down. See, the problem is the gripping, right? So grabs it, and yeah. So now when it moves down, up. Okay,
Just like the rainy background on my computer, my heart is in a rainy day. How can I miss this? It's such a crucial component that the gripper should be able to pick up the rubber ducky, but it was inconsistent. I wonder if it was my fault. I tried with an orange, but it was too heavy. I tried with some Dorito chips, but I ended up eating all of them. I thought about many solutions, and that's all I think about every time I come home after work. Finally, it was 3 a.m. and here's what I came up with.
yeah, honestly, now that I think of it, I mean, it makes sense for a rubber ducky to be in the water, you know?
While I'm at it, I decided to have a little fun and have the robot draw a little heart during Valentine's Day. Check out my other video for this tutorial if interested. Okay, back to business.
Hang. Grab it. Good shot.
Hang on. Rewind this. Pause. Play this again.
I think I figured it out. It took me a while, but the problem is I was moving the arm diagonally, and that causes the rubber ducky to tilt over. And so the trick now is if I just move the arm vertically up before moving back to the camera position, then I think that fixes the solution, or that fixes the problem. And it's working really well right now. I am so excited. It is so exciting. Look at it. This is 5 out of 5 right now. It'd be 6 out of 6 if it works again. It's gonna pick it up. There you go. Go straight up and then move back. See? See? It works. It works. It's working, guys. Get it in. One more time. Hold on. Just one more time. Okay. It's gonna pick it up. Go straight up so it doesn't fall. And then back. Yes! Yes! Oh my gosh. It's pretty consistent now. Okay. Yes. We got the ducky. Yes. Yes. I'm right here. I'm right here. I got a rubber ducky. Oh my goodness.
Good boy.
From the one who could free my soul, but God reached down and He saved me, and God in mercy forgave me. I was a dead man walking to the gates of hell. I was a child of wrath with no way to tell. I was lost, but God.
Got a rubber ducky. You saw it. You saw it on the. You saw it. Oh.
No control, I was living for myself. Now I live for Christ and nothing else. I rejected love, refused His grace. But now His grace and love are